Dear students, now we will discuss on very important topic, that is a degree of freedom of a system. Suppose we have a system where liquid in equilibrium with vapors. There is a liquid is there and vapors is also there. Both are the in equilibrium. Okay. Therefore, there is a vapor pressure and temperature is related in this system. And the vapor pressure is nothing but pressure exerted by the vapors. Therefore, the pressure is related to temperature. As temperature is increases, its vapor pressure is also increases. If we suppose temperature is fixed and vapor pressure is decreases, then you can also the temperature is decreases. Therefore, these two quantities are interrelated to each other. Vapor pressure increases, it means the temperature increases. And if you decreases or increase the vapor pressure, also the temperature increases. And when you decreases the temperature, vapor pressure is also decreases. Okay, this is the interrelated to each other. Whether you vary the pressure or you vary the temperature. If you suppose make a pressure constant, then temperature if you vary, then at a particular temperature you can use the pressure, vapor pressure. And at a particular vapor pressure you can give the values of temperature. If decreases, the temperature is the decreases. Okay, therefore in this equilibrium, the pressure and temperature, any quantity you vary and one quantity you make constant, then the equilibrium is not disturbed also there, and it gives the perfect value of other quantity. Therefore, this system is a or degree of freedom for this system is 1. Degree of freedom for this system is 1. Therefore, we can define degree of freedom as number of intensive properties. Okay, intensive properties are pressure, then concentration and the temperature. These are the intensive properties. Intensive property means the property does not depends upon the mass. When you add the mass of a substance, there is no change in pressure, no change in concentration and no change in temperature you found there. Therefore, it is mass independent properties. And extensive properties are volumes are the extensive property, number of moles are the our extensive properties. Okay. Therefore, number of intensive properties must kept constant in order to define other intensive properties of system. Therefore, degree of freedom gives idea about the system, give the idea about the system at equilibrium. All the pressures, temperatures, you can get the idea from the degree of freedom. That intensive properties, all the system can be equilibrium system can be described by the degree of freedom. Degree of freedom gives the idea about the equilibrium, the system at equilibrium, how much there is a freedom is there. Suppose we have other system is there. Okay, we have a gas system is there. Okay, in a container there is a gas is filled, and we have the relation for the gas PV is equal to nRT. Okay, therefore you decreases the pressure or increases the temperature, decreases the temperature, will decide the volume of system. And you decreases the pressure and the temperature, equilibrium is not affected to the certain range, to the certain point. Equilibrium unaffected when you small changes in temperature and pressure takes place. Therefore, these two quantity is the variable, pressure and the temperature is variable, gives information about how much volume is there without disturbing the equilibrium. Therefore, the system is, pressure is variable, temperature is also variable, system is, you have to describe this system. Therefore, this system is the degree of freedom for system is equal to 2. Therefore, system is called as the bivariant system. Now we have third system is there. Okay, if ice is in equilibrium with water and water is in equilibrium with the vapor. Okay, thus this system is at a particular pressure 4.58 pressure is required, mm pressure required, and 0.01 Celsius temperature is there. Then and then this system is appears. If suppose you make this one of the system is constant and you increase the temperature, the equilibrium is disturbed. If you pressure make constant and if you temperature make constant and pressure increases or decreases, equilibrium will disturb. At a particular point, you should have ice, water, and the vapor. Okay, therefore there is, when you change the pressure, the equilibrium disturb. When you change the temperature, equilibrium disturb. When you change the both, equilibrium is disturbed. Therefore, in this case, this is the zero freedom system. This is the degree of freedom is 0. Okay, when gas system was there, when you you decrease the temperature or pressure decrease, there is no change of the system there. Equilibrium is maintained, therefore it is a bivariant system. Okay, like that way we can describe the degree of freedom. Okay, therefore the degree of freedom it's difficult to understand. Therefore, introduce one rule. By using that rule, you can easily predict the degree of freedom. That rule is stated as the equilibrium. There are the phases, okay, and those phases are not affected by the gravitational force and the electrical force or the magnetic field, which is only affected by the pressure, concentration and the temperature. The degree of freedom and number of components, number of phases is related to each other by an equation. That equation is degree of freedom is equal to number of components minus number of phases plus 2. By this rule we can calculate the number of degree of freedom. Therefore, previously we described that number of example was difficult to understand. Therefore, by using these rules we can easily predict the degree of freedom. Let us try this equation for some systems. The first system is a gas system, gas in a vessel, number of phases, number of components, and degree of freedoms. In this case, number of phases is only one, number of components is again only one. Therefore, our degree of freedom will be is equal to C is the 1 minus 1 plus 2 is equal to 2. The system is 2 means the system is the bivariant system. Remember, if degree of freedom is 2, the system is the bivariant, and temperature and pressure, this system is temperature and pressure variant. If you vary the temperature and pressure, there is no change in equilibrium, and we can define the system, we can describe the system, we can give the volume of the system when you change the temperature and the pressure. The second example, liquid in H2O liquid in contact with the vapor or equilibrium with the vapor. In this system, the phases are two, vapor phase and the liquid phase. Two phases are there. Number of component is 1 because it's the chemical component present, chemical composition present in this case is only H2. Therefore, number of components is 1. Therefore, degree of freedom will be is equal to our that is C is our 1 minus 2 plus 2 is equal to 1. Therefore, if degree of freedom is 1, the system is the monovariant system. And system, if it is monovariant system, therefore it is only temperature variant or pressure variant system. You can vary the pressure or you can vary the temperature. Then and then this equilibrium is the maintained. This is monovariant system. Then we have the system ice is in equilibrium with the liquid water, liquid H2O, and liquid H2 is in contact with the vapors. In this system, there are the three phases, and it is chemical composition only one is there, H2 is there, one is there. Therefore, degree of freedom will be is equal to number of components 1 minus 3 plus 2 is equal to 0. Therefore, it is a non-variant. If there is 0, it is non-variant system. Therefore, it is 0 degree of freedom. Okay, that system has a 0 degree of system. Okay, by using this rule, you can find out the how many degree of freedom is there, which is given by the Gibbs. Okay, this is all about the degree of freedom. Thank you very much.